Hello everyone. So today we want to take a quick look at singular diagram and wiring diagram. Professionals in various industries rely on technical or engineering diagrams to understand what components are included in a system, where these components are located, and how they connect and interact with each other. Understanding a visual representation of a system is often easier than reading high technical text describing the system. Like the diagram I have here now, this similar diagram, it's easy for someone to understand it. Now we have the grid supply here, we have the gen set here, we have the changeover here. It's easy for someone to understand it down, to have it written down. So we use this singular diagram in electrical and electronics to easily identify the interconnection of different components. So I have 4 pages here. This is page one. The page one shows a typical solar system single line diagram in Africa. And these make use of what? Pictorial symbols. These are, look at the pictures: solar panel, inverter, batteries, changeover, generator. I'm making use of pictorial symbols. What are pictorial symbols? A pictorial symbol uses pictures to represent the different components. It uses realistic picture to make the various components easy to identify. It is easy for someone, for average person working on the system to understand it. Don't need to be highly technical to understand this. It's easy to what? To identify. I'm using pictorial symbol here. Let's go to the next page. On the next page, we have look at this schematic. I'm using schematic. It's still the same. Typical solar system, singular diagram. This one is also a singular diagram. But I'm using what? Schematic symbols here. Schematic symbol. Look at solar panels here. You have the solar panels that we have here. Look at solar panels here. So I'm using what? Schematic symbols here. What are schematic symbols? The schematic symbol uses standardized symbols and simple line diagram to represent various electrical and electronic components. The standardized symbol makes it possible for any experienced professional to understand the schematic diagram. So these are used by experienced professionals. Experienced professional will not be there using pictorial symbols, panels, inverter, batteries, because these are real pictures. They are, like now, I've specified the inverter that I'm using here and the battery here, but here it's not specified. Someone will know that this is not an inverter. So, but for this pictorial symbol, these are real pictures. We don't usually use this. Professionals don't usually use this, but for those that the average person can give them this so that they're easy for them to understand. So these are single line diagrams. These are makes of pictorial symbols. Single line diagram. You can see it's a single line. Look at the supply from the grid. Supply from the generator is a single line. Look at also this. I'm using schematic symbols here. That is different. Look at the batteries here. 12 volts, 200 Ah. They are what? Schematic symbols. It's different from this one. That is what? That is a pictorial symbol. Now let's look at wiring diagram. Let's look at the wiring diagram here. Wiring diagram, it will identify all the lines that are there. The difference between a wiring diagram and a single diagram is that a wiring diagram shows the details of the interconnection between different components. Unlike a singular diagram that uses single line to represent all the conductors, wiring diagram shows all the conductors in the system with different lines. Look at this. We have supply from the grid. We have the live represented as red, and we have the neutral represented by black. Also supply from the gen set. Supply to the distribution board, live and neutral. But for single line diagram, it's just a single line. Just a single line. Look at this. Supply from the grid, supply from the gen set, supply AC inputs to the inverter, AC outputs from the inverter. Just a single line. But for wiring diagram, look at you're having different line and neutral. This is a single phase system. If it's a 3-phase system, it will have 4 wires. That is L1, L2, L3. That is red, yellow, blue. Then you have black. If it's a 4-phase system, that's for wiring diagram. But for single line it will always have what? One line. And this single line diagram, the single line represents more than one conductor embedded on the system. The single line that they are seeing, it represents 2 conductors. That is live and neutral. But it's only one that will be shown in a single line diagram. So this is a typical solar system single line diagram in Africa using pictorial symbols. So for people to easily understand it, and this is what the same diagram, but I'm using what? Schematic symbols here. That is the difference. And also we have the one here. I'm using pictorial symbols, but this is a wiring diagram. This is a wiring diagram because it's showing different wires, live and neutral, showing these different wires. And also this one is also a wiring diagram, but it's what? is using what? Schematic symbol. Look at the live here and neutral. This is the genset, distribution board, inverter. The battery is connected together. They are connected in series, positive to negative, positive to negative, positive to negative, positive to negative. So you have it interconnected this way. So let me use this to explain. We have the solar array here, the solar panels. They are connected together. So they connected together, positive to negative to negative to increase the voltage. They are connected to the PV input breaker. The PV input breaker. So if you want to disconnect the solar panels, you can use these breakers to disconnect it. Then from there, it goes into the what? DC input of the what? Of the hybrid inverter. This hybrid inverter, this is hybrid inverter, it can take solar panels directly. It has a charge controller inside it. Then from there, we also have a DCSPD, the DCSP to divert SS currents and DC surge currents. So we have this DCSPD there. That is for the PV input breaker. So that is for the PV part. Also for the battery, you have the battery bank here. After the battery, you have the battery breaker. In case you want to disconnect the battery supply, so you have the battery breaker here. Also, that is from this for DC side. So I've explained the solar array, that is the solar DC input, and also the battery input, that is for the DC side. Then for the AC side, you have the grid supply coming from the grid. Then after the grid, we are now going to the generator genset supply. The reason why we make use of this is that in most African countries, the grid is not reliable. So most households, most businesses, they have their what? Genset that they use as alternative. So we have a changeover here. Whenever the grid is not available, someone can change to gensets. That's why we have this changeover here. Then the output of the changeover, one of it we go to the what? We have another changeover here. Then one of it we go to the inverter AC input to be charging the battery so that you can use the grid or genset to charge the battery. So we have inverter AC input. This inverter AC input is to charge the battery with the what? With the inverter. So you can charge the grid or genset can be used to charge the battery. So that's how we have this. So to have its own AC input breaker. In case you want to switch it off, no, I don't want the grid to charge the inverter, you can switch it off. So that is one of the reasons why we have this here. Then we have another changeover here. This one can be a changeover or something can be a bypass switch. Some people use bypass switch. Some people use bypass switch. So for this, the function is that you have two connections. So this one will be the output of the genset, of the grid and genset. This is the output. Then this is the inverter AC output. The output from the inverter is this is it here. This output of the inverter. So it's now coming here. From here, we want to select the AC output breaker. The reason why we have this is that in case the grid or the genset is fault, or in case the grid or genset is available, but the inverter is not available, so I can easily switch this to the grid or genset. But sometimes I mean that the inverter is faulty. The inverter might be faulty, and since it's faulty, we need to take alternative. The alternative that we can use with what will be the grid or genset. So you have to switch it back to what? To the grid or genset. So that is one of the reasons why I have this here. So that in case the inverter is faulty, it's down and it needs maintenance. So, and because of that, we cannot say there will be supply at there will be output supply. So you have to switch back to the grid or genset. So that is one of the reasons why we have this. I hope the explanation is clear. We also have the earthing terminal. So the earthing terminal take the DCSPD to connected to the earthing. Also the ACSPD connected to the what? To the earthing. Distribution board will be earthed. The genset too should connect to the earthing, so it will be connected. Also the solar panels, they should be earthed together. The earthing should be it will be connected to the earthing so that they will be at the same voltage level in case there is straight current can quickly flow to the ground. Also for the distribution board and other components. So that is what we have here. So on page 1, we have the typical solar system single line diagram, SLD in Africa using pictorial symbols. This is not common in other continents, other continents outside of Africa where they have reliable grid. But in Africa, Nigeria and most other countries that there is no reliable grid. This is diagram that we mostly use, make use of uh, two changeovers or one changeover and one bypass switch. So I can can interchange between grid and genset. So one changeover will interchange between grid and genset, while the other one will be used to interchange between inverter and grid or genset changeover or bypass switch. So that is what this one for. And we have the batteries, then we have the what? We have the solar array. Then we make major use of a hybrid inverters that can accept AC input from the grid or genset. That is why we have this. So the inverter AC input breaker is here. The inverter AC output breaker is here. You have the SPD here, distribution board here. And the second page is the same with the first page, but just that for the first page, you are using pictorial symbols, while for this, you are using what was schematic symbols. So these are schematic, they are purely schematic symbols. The inverter, look at the inverter here, look at the inverter here, look at the batteries here, look at the batteries here. They are making of what schematic symbols. And these are single line diagram. You can see it's a single line. But for the third one is what? Wiring diagram. This is wiring diagram. Live and neutral are represented differently. So this what is a what wiring diagram. We're using pictorial symbol. It's always the same pictures. Why this is what is also a wiring diagram, but I'm using schematic symbols here. Look at the inverter here for the pictorial symbol. Look at the inverter here for the schematic symbol. Look at the batteries here for the pictorial symbol. Look at the batteries here. It's clearly identified. It's clear here that the batteries are connected in series, positive to negative, positive to negative, positive to negative, to increase the voltage. So the output voltage here will be 12, 12, 12, 12. That is 12 times 4. That is 48 volts. So this inverter is 48 volt inverter. So unlike this, might be difficult for someone to identify that they are connected in series. But using schematic symbol, it's clear that they are connected in series. So that's one of the advantages of schematic symbol. And we also use wiring diagram. Wiring diagram will give more details than single line diagram. You can see wiring diagram is easy to identify that this positive, this negative, this positive, this negative, this positive, this negative, how they are connected. So wiring diagram gives more details than single line diagram here. It's just showing the breaker. Look, I don't even know how the batteries are connected, if they are connected in series of power. It's just showing the interconnection this way. So singular diagram gives less details than wiring diagram. Gives less detail than wiring diagram. Wiring diagram is used when you need more details connection. But singular diagram is the most common because it's simpler to sketch. It's simpler to sketch. It's the most common. We see electrical professionals asking for singular diagram, SLD, SLD, SLD. People don't usually ask for wiring diagram. Wiring diagram is high technical. It takes time to prepare. So I hope you understand that. Thank you very much.